Today we'll be learning how to use Cramer's rule for a system with 3 linear equations with 3 variables. Please ignore the pounding in the background. That's my brother. You know, playing piano like a madman. Anyway, so let's get straight to the point, since you're probably not watching this for fun. Probably just watching this to learn this real fast. So, let's say we have... Actually, Cramer's rule uses the determinant a lot. So, we're going to remind you how to find the determinant of a 3x3 matrix. So, if you guys remember, to find the determinant, you need to know how to find the determinant of a 2x2 matrix first. So I'm going to remind you of that as well. 2x2, so 2x2. So the formula is really simple. It's just A times D minus B times C. The diagonals times each other, basically. Well, the diagonals multiplied by themselves, then subtracted. The easiest way I can say it. So, now we know that. Let's move on to a 3x3. Let's make the least original name for each of the variables as possible. There, A, B, C, D, E, F, G, H, I. So, what you do is called expansion by the first row. So you take the first number in the first column, and you cover up that row and column that it's in, and you're left with E, F, H, I. So what you do with that to find the determinant is you multiply A times that, the determinant of that little matrix, E, I minus F, H. Then you take the second one, and you, again, when you subtract first, then you do the same thing. Cover up that row and column, and then D, I minus F, G. And then finally, the third number, C times D, H times E, G. Like that. So, okay, you know how to find the determinant. Great. Load. How about now? Great. No, not too far. Sorry. Technicalities. Whatever. You know what I mean. Maybe. Okay, so we've got this wonderful system. Now to solve it, we have to put it into a matrix, which basically just means taking all the variables here. A, B, C, D, E, F, G, H, I. Oh, hello again. And then I'm just going to put M, N, O. X, Y, and Z, forget them for now. Okay, so we've got this. We're just going to find the determinant, but I'm not going to actually do the formula again, because you know how to do it. So, wonderful. Pretend that's the determinant right there. Okay, so now what? How do I find X, Y, and Z from that? Well, we actually need to find more numbers. I know, fun. Okay, so you see this lovely column right here? Yeah, forget about that column. Put this in there instead. We're going to make a completely new matrix over here. M, N, O, B, E, H. That's obviously an E, and that is obviously an O. O. Close enough. C, F, I. That's not a T, that's an I. Forget my handwriting, I'm sorry. Okay, so we find another determinant of this matrix here, and we call it determinant of X. Okay, great. Another number. Well, actually, no. We're going to replace, instead of replacing ADG, we're going to replace this row with a completely new matrix. Okay, A, D, G, M, N, O, C, F, I. Guess what? Yeah, we find the determinant of this one, and it's determinant of Y now. That's a Y. Now we replace the last column, C, F, I. A, D, G, B, E, H, M, O. And this determinant is called determinant of z. Okay, we've got determinant of x, y, z, and determinant. Okay, I'm going to erase this for more room. One sec. Okay. So now what? We've got 4 numbers here. How to find x, y, and z from that. Simple, actually. It's very, very nice. Put determinant of x, and you divide that by the determinant. And you do a similar thing for the other ones. Determinant of y over the determinant, and determinant of z over the determinant. And that's how you find them. So, to hopefully make this make more sense to you, I'm going to actually show you an example. If Dosiri wants to load. One moment. There! Okay. No! Okay, maybe not. Wait for it. There we go. Okay, so we're gonna go with this really fast. 3, 2, 1, 1, 2, negative 3, 1, 5, negative 4. I'm actually going to ignore the answer part. So we have this. Find the determinant of that, which is actually equal to 26. I'm not going to bother doing that because you know how to do it. And you could also use a calculator, because there's a nice function that you can use to find the determinant of a matrix. Okay, so then we replace it with the answer row. That's a 2. 1, 2, negative 3, 1, 5, negative 4. And the determinant of that is equal to, actually, 26 as well. I'm not going to bother writing out the other ones, so determinant of y is equal to 26 as well, if I believe. Yes. And determinant of z is equal to negative 26. Okay, so we've got determinant, which equals 26. We've got determinant of x, which also equals 26. We've got determinant of y, which also equals 26, and determinant of z, which wants to be different, and so it's negative 26. So what's x, y, and z? You remember how to find this, I hope, which is 26 over 26. Y is 26 over 26, and z is equal to negative 26 over 26, which means they simplify to 1, 1, and negative 1. So just to double check our answers, because that's always a good thing to do, we're going to go back to the original equation, and we're going to plug those answers in. And I'm just erasing, because erasing's fun. No, it's not. It's tedious and boring. Anyway, so 3, no wait, actually I'm going to put x, y, and z here so you can remember what it was. X, y, and z. 1, 1, negative 1. Okay, so 3 times 1 plus 1 plus negative 1 equals 3. Well, let's see if it does. 3 plus 1 minus 1 equals 3. That's 4 minus 1 equals 3, which is 3 equals 3. We're right. If I had more time, I would show you the other ones, but you can do that yourself. So have fun with Cramer's rule. It's actually, to me at least, one of my more favorite methods. So have a lot of fun. Go live your life. Play video games and stuff, whatever you want. I don't know. I don't really know you. So, yeah. Just hope you get a better grade in math because of that. Bye.